Hello, I'm going to be talking about multiple sclerosis. Okay. So on the agenda today, this is kind of what we're going to just go through, a little introduction, then the anatomy, the physiology, the pathophysiology of it, diagnosis, treatment, and AI, and then the demographics. So introduction, multiple sclerosis, MS, is a chronic disease that affects the central nervous system. It occurs when the immune system mistakenly attacks the protective covering of the nerve fibers, disrupting communication between the brain and the rest of the body. So my presentation is going to just explore the anatomy of it, the normal physiology, what happens in the pathophysiological changes, along with diagnosis, treatment, and the options, and then also impacts on individuals just worldwide. So let's start by looking at the system most affected by MS, the central nervous system, the CNS. This includes the brain, the spinal cord, and the optic nerves. These structures control everything from movement to balance, sensation, and even vision. Within the CNS, multiple sclerosis specifically targets the white matter tracts, which consist of long myelinated axons. Myelin acts as insulations around like the electric wires, speeding up the nerve signal transmission. Damage often appears in these key regions here, the cerebrum. What else do we have? Like motor control and cognitive functions. The cerebrum impairs coordination and balance, and damage to the optic nerves can cause like a visual disturbance, blurred or lost vision. So here you can just kind of see where in the CNS it kind of impacts. So let's zoom in this slide. It demonstrates how multiple sclerosis affects on the cellular level of the CNS. So the primary target is the myelin sheaths that wraps around neurons. It's produced by specialized glial cells known as oligodendrites. When the immune system mistakenly attacks this myelin, the protective covering, as you can see here, is lost of these myelin sheets, these blue ones right here. However, in MS, even these beneficial cells can contribute to inflammation and scarring, referred to as sclerosis. So multiple sclerosis, that's where that comes from, which gives its disease its name. This diagram here compares what a healthy nerve looks like to one that is affected by MS. Okay, let's see. So the physiology part of it is in a healthy CNS neuron send electrical signals called action potentials down axons. These signals jump between nodes of the Ranvier. As you saw in the previous one, it was that little yellow part. So like this part right here. Um, and it is in a process called solitary conduction. Thanks to the insulating myelin cells formed by the oligodendrites at synapses, neurotransmitters such as glutamate or GABA, GABA assist in passing messages between neurons. Dopamine helps modulate mood and motor control. This fast coordination signaling is essential for everything from movement to memory. Let's see, neurons rely on the sodium-potassium pump to maintain their electrical charge. After neurotransmitters are released, enzymes such as MAO or COMT break down the surplus to prevent overstimulation. BPM is a key protein that helps the myelin shelf together, like hold it together. Hormones also play a significant role. Cortisol from the HPA axis helps reduce inflammation, while estrogen and testosterone help regulate the immune system. Thyroid hormones, they help, excuse me, support brain metabolism and promote myelin repair. Right. So multiple sclerosis is an autoimmune condition where its body attacks its own immune cells, especially the T cells, mistakenly cross the blood barrier and attack these myelin cells. Myelin usually normally it insulates the neuron and facilitates the rapid movement of these electrical signals down the axon, so it speeds up that process. When this protective covering is stripped away, impulses could slow down or get entirely blocked. This demyelination disrupts communication between the brain, the spinal cord, and the body. Over time, inflammation doesn't just remain at the myelin, it starts to damage axons themselves, particularly if the immune attack persists. This process leads to long-term neurodegeneration and atrophy of the brain or spinal cord in MS patients. Many MS symptoms can be traced back to the damaged nerve tracts. When motor pathways lose this myelin, muscle control is affected. So patients can experience weakness, tightness, or even sapphatic movements. Disruption in sensory fibers cause numbness, tingling, or shooting pain. Visual symptoms, again, like the blurry vision, um, often arise from the demyelination of the optic nerve. Fatigue is another common symptom. It likely stems from the damage of the neurons requiring more energy for impulse transmission. MS can also disrupt temperature regulation, which is why symptoms may worsen with heat. This leads to issues with bladder control, bowel function, and even heart rate regulation. MS essentially disrupts many of the parts normal homeostatic systems. Sorry. So when diagnosing MS, typically it will involve multiple tests. An MRI is a pretty good standard to start off with. It reveals the white matter lesions in the brain and the spinal cord, often occurring in specific regions. A lumbar puncture is also used to test for the oligoconial bands, I believe they're called, oligoconial bands of the CSF, which are immune proteins found in the CSF of many MS patients. Evoke potentials measure how quickly electronic signals travel through nerves, which slows when the myelin is damaged. MS is a chronic condition. Once it's diagnosed, patients must manage it for life. Symptoms may manifest or flare-ups can also pop up. The primary goal of treatment isn't a cure, but rather to reduce relapses and slow down the progression. Disease-modifying therapies from the cornerstone of MS is treatment. Interferon beta works by dampening the immune response. It acts almost as an antagonist inflammatory cytokines, help slowing down T cell activation. So these are just some of these medical treatments that could be used. Side effects that could occur is immune suppression. So it is pretty much you are at higher risk for infections. Drugs may alter neurotransmitter levels, so like it could affect your mood, your energy. AI diagnosis and treatment, machine learning models analyze MR scans to try to detect these lesions earlier, and AI-assisted tools help track progression and tailor medical plans, medication plans. Who is most affected by MS? Typically, it does get diagnosis between the ages of 20 and 50. Um, Women are 2 or 3 more times likely than men to develop MS. Race, mostly common in white individuals or Northern European descent. Geographically, higher prevalence in countries further from the equator. Globally, the US prevalence, nearly 1 million people living with MS. There is 2.9 million people worldwide, and then a high prevalence in the US, Canada, Northern Europe, and Australia. Survival rate, most people can live decades after they get diagnosed, but their life expectancy is reduced by 7 years after that. Mortality rate is rare. Um, it's rarely fatal. Complications, are the main cause of death in MS. And these were the references that I used. Thank you.